Welcome back to Daily Dose of Space. For hundreds of millions of years after the Big Bang, the universe was completely dark. There were no stars, no galaxies, no planets, no light sources of any kind. Space was filled with hydrogen and helium, slowly drifting apart as the universe expanded, but nothing was shining. This period is known as the Cosmic Dark Ages. And then, something changed. The first stars ignited, and with them, the universe transformed forever. They ended the darkness, rewrote cosmic chemistry, and made everything we see today possible. This is the story of the first stars, and why the universe we live in exists only because of them. The universe after the light turned on. After the cosmic microwave background was released, the universe entered a long, silent phase. Matter existed, but it was simple, almost entirely hydrogen and helium, with no heavier elements. Gravity slowly pulled gas together, but the process was painfully slow because there were no efficient cooling mechanisms. Without cooling, gas cannot collapse easily. Without collapse, stars cannot form. For millions of years, nothing happened. The universe expanded, cooled, and darkened. Large-scale structures were beginning to form invisibly, guided by dark matter, but no light escaped to reveal them. This was a universe full of potential, but no ignition. How the first stars formed. The first stars formed in a way completely different from stars today. Modern stars form inside dense molecular clouds, rich in heavy elements that help radiate heat away. The early universe had none of that. Primordial gas could cool only through very inefficient processes. As a result, when gravity finally overcame pressure, it did so on enormous scales. Instead of forming many small stars, the early universe formed a few extremely massive ones. These were the population 3 stars. They were giants, often tens or even hundreds of times more massive than the Sun. They burned hot, lived fast, and died young. And most importantly, they were the first sources of light since the Big Bang. Stars. Nothing like our Sun. Population 3 stars were fundamentally different from anything we see today. Because they contained no heavy elements, their internal physics was simpler but more extreme. Nuclear fusion proceeded faster. Radiation pressure was enormous. Their lifetimes were incredibly short, sometimes only a few million years. But during those brief lives, they completely altered their surroundings. Their intense ultraviolet radiation began to ionize the neutral hydrogen around them, slowly ending the cosmic dark ages. Regions of space that had been opaque became transparent once again. Light could travel. The universe was waking up. The first chemical revolution. Before the first stars, the universe was chemically simple. After they died, it was not. When these massive stars exhausted their fuel, they exploded as supernovae or collapsed directly into black holes. In those final moments, they forged the first heavy elements: carbon, oxygen, silicon, iron. These elements were scattered into space, mixing with primordial gas. For the first time, the universe had the ingredients needed to form planets, complex chemistry, and eventually, life. Every atom heavier than helium in your body was created in stars like these. Without the first stars, the universe would remain dark, simple, and sterile. Why we have never seen them directly. Despite their importance, no population 3 star has ever been directly observed. They lived too briefly. They existed too long ago. Their light has been stretched, weakened, and obscured by billions of years of cosmic expansion. What we know about them comes from indirect evidence, from the chemical composition of ancient stars, from simulations, From subtle signatures in the early universe, new telescopes, like the James Webb Space Telescope, are finally pushing close to the era when the first stars may have existed. We may soon detect the galaxies they influenced or the environments they shaped, but the stars themselves remain ghosts. Why everything depends on them. The first stars did not just add light to the universe, they defined its future. They determined how galaxies formed, how gas cooled, how black holes grew, and how structure emerged on every scale. They ended the Dark Ages and replaced them with a universe capable of complexity. In a very real sense, everything that followed was built on their ashes. The first stars are gone. They burned, exploded, and vanished billions of years before Earth existed, yet their influence is everywhere. In the galaxies we see, in the elements we are made of, in the fact that the universe is visible at all. And the unsettling thought is this: if the first stars had formed just a little differently, the universe we know might never have existed.